This set of tutorials puts fundamentals of data analytics into a simple system of 5 building blocks. By using those 5 blocks, you can make up a logic to perform any data analytics task, from sourcing your data, processing your data, slicing and dicing, and then producing your reports. My goal is to help you in transition from being concerned and not confident with data to being absolutely ready to go and being prepared to anything your data can throw at you. Okay, today we're going to be covering probably the most important tool in data manipulation and data analytics, which is the joins. The joins, as they say, as the name suggests, allow you to join two different data tables. So it's probably the only tool that lets you use two tables together and derive value for your analysis from both of them. And with that, let's get into it. Okay, joins. The plan for today will be, we'll go through fundamentals on how they work, and then we'll look at, as usual, some pitfalls of what could go wrong with them. And then number 3 will be, we'll look at some examples in real application KNIME.
Okay, let's see what joins do. Well, first of all, joins are effectively it's an action between two tables. So we've got table number 1 here and table number 2 here. For joins to work, they need to have a set of columns. It could be just one column that is being referred to as the key. Effectively, something for the both tables to join on. Say, for example, there is a numerical column which is effectively having 1, 2, 3, 4 in this column in the left table. And then in the second right table, we also have this very similar looking column, but it could be slightly different in terms of values. Say, for example, there could be 1, 2, 3, then 5, then 6, then 7. Okay, so the idea of a join effectively to, in both tables, to have a column or a set of columns that would allow you to establish this link. Effectively, this row here will correspond to that row in the second table, because 1 here equals to 1 there, and then obviously the second row will correspond to the second row in this table, and so on. 3 will correspond to 3. Interestingly, 4 doesn't have an equivalent, so therefore only 3 rows from the first table will join to the 3 rows in the second table. Effectively, the row with number 4 will not have a joining record in the second table, and similarly the rows 5, 6, and 7 do not have a joining rows in table number 1. So effectively, this is how the joins work in an outset of what the task of a join is. And the next thing that we'll do is we'll have a look at the actual mechanics of how joins happen. Okay?
Okay, let's see the mechanics of joins. Assume we've got a couple of simple tables, and as you can see, the column in green called ID looks very similar in both tables, and therefore it could be used as a join key. Now, in a very simple explanation, a join is effectively where every single row from the left table will go through all rows in the right table, find a match or doesn't find a match, and this is how it works. So basically every single combination will be considered. Let's see how it does it in reality. So the first row goes through all the rows of the second table, finds a match, takes the matching name across into the resulting table. The second row with a value B also finds a match, gets that name, brings it across into the resulting table. And the last row with a value C goes through everything again, doesn't find anything and gets nothing, and as a result gets a value null. Now here I've pointed how those parts of the resulting table could be referred to in the future. You can just come back to it and have a look at those explanations and labels. Okay. Now, we have seen the mechanics of joins. Let's see what potential problems we can have with joins. Let's say in a very simple example, if I have just one column in my table and it happens to be a key, and that's table 1, and then on the right hand side, table 2, we have also the same key. And let's just say there is no other values but A in both. Now, what happens because of the mechanics of joins is this. When each row will go through from the first table will go through the second table, it will actually find multiple matches. So this A row from the left table or table 1 will find 2 matches in the second table, table 2. So as a result, it will create 2 rows on the output. Now, the second row with value A, the same thing will happen. It will find a match in the first row of second table and the second row of second table. In both cases, there will be ticks and it will result in extra 2 rows. And then row number 3, guess what? The same thing happens. It finds matches in both rows of the second table. And as a result, there is another tick in both, but there is also 2 extra rows. When we add those up, we get 6 altogether. Now, this is what is sometimes referred to as join explosion, but a proper name for it, I think, is a Cartesian product. Effectively, it's a multiplication factor because the key thing here is join considers every single combination of matching keys on both sides, and that's why we've got extra rows. Now, is that a problem? Oh, sometimes it could be, because effectively, if you start with three rows in your tables, in your data, and sometimes you get those extra rows, they effectively duplicate it. They shouldn't exist in the first place, and that could create a problem. Now, what is the solution to this problem? The solution to this problem is to make sure that at least in one of your tables, for example, table 1, table 2, if we have 3 identical values in table 1, you need to make sure that there is only one in value, one row with that value in the other table. What this means is, at least in one of the tables, this value will have to be unique. Okay, and that's what makes it work, and that's what prevents the explosions. So, for example, when it goes and matches each of the rows, it will only find one match for each of the rows of the table 1, and as a result, on the output of this join, there will only be three rows. Okay, so the problem is we have some duplicates in the key column. Well, it's okay generally as long as it only happens in one table, not both tables. And that's how you prevent join explosions. Okay. Now, sometimes you don't know whether it happens or not. How can we check whether we have join explosion or not? I will try to draw some couple of tables, and let's assume these are the matching parts of those tables, right? So the key principle here that these parts of the tables, the ones that don't match, they will obviously result in absolutely the same number of rows as the initial tables, right? Because they don't match to anything, nothing should happen. Say, for example, if you've got 3 rows here and then 5 rows in the second table that don't match. But then when we have 2 rows here and 2 rows here, and those match. And let's assume there was some explosion in it, right? So, and what will happen is in the resulting table, obviously, this will become that part, this unmatched will become that part, and then there will be rows in between that actually matched. So now we definitely have 3 rows here, we have 5 rows here, but if explosion happens, we will have more rows here. Let's say those records were complete duplicates and it's a 2 by 4, 2 by 2 equals 4 rows, right? So in the resulting table, we now have 3 plus 4 plus 5, that's 12 rows altogether. Now, how do you know from this picture whether there is a duplication? So the formula is effectively like this. To check that one table has been exploded, you've got 5 rows on the input of that left table. You basically need to add up what did not match with the rows that did match in the output of the table. So for example, if you go 3 plus 4, that equals 7, and therefore it does not equal to the initial 5. The conclusion is there is an explosion. Okay, and this is how you can check for it. Alternatively, if there was no explosions, the results will be like this. There will be 3 rows here, 2 rows here, and 5 here. And total rows in the output of the join, it will be 10. Yep. But to check each table, you will have to say, okay, I used to have 5 rows in the input table on the left. Does this give me 5? Yes. So I do not have any explosion. You also need to check for the left table, we used to have 7 rows in there. Now, what do we have now? Effectively, it's from here to here, 2 plus 5 is still 7, tick, no explosion. So effectively, the formula for checking whether there is a join explosion, you need to add together unmatched rows plus matched rows, and check against the rows of your initial table, and do it for both tables. And that's how you know whether there is explosion or not. So I hope it gives you enough ammunition to deal with join explosions. And the solution here is effectively to make sure that at least one of your tables has join key being completely unique. And we'll see how we can use one of the 5 other tools to make sure that it's unique.
Okay, let's do a real demonstration in KNIME. As you remember, KNIME allows you to use all 5 fundamental blocks very simply without any code. In this particular case, I've got a couple of tables. This is my left table, very similar to the example that we had in the mechanics part of the video. So we've got 3 rows with transaction date and A, B, C being the values of the ID column, which is our join key. And in the right table, we've got A, B, D, and F. So obviously A and B we expect to match, and D and F we don't expect them to match. Now, when we start typing into our node repository and we type join, the node in KNIME that does the join function is called joiner. Now, if we connect our inputs to the joiner, go in, what you see first is the join mode, and before we go in there, let's just pick our key. You just hit this button here and then just pick the columns that you want to nominate as your join key, and as you can see, you can add more. So you're not limited to just having one column as your join key, you can have as many as you like. Now there is a second tab that you sometimes need to populate, but just let's leave it as is for now. And let's try to run it. We run it, we'll look at the output. And by default, because it was in the inner join mode, it only gave us matching rows. As you remember, A and B values of the join key are actually in both tables, and as a result, we have the combined product of those tables, which is transaction date and the name. And this is the most typical scenario why sometimes you use joins, because you need to add some additional information, like you had the transaction dates but you didn't have names. Now we've got names. Alright, but that's not the end of it. Let's just see what will happen if we change the inner join to left outer join. And effectively what it means is left means all rows from your left tables will become your effectively the content of your table, and then the name column will be populated for those rows that find a match, and it will be empty for those rows that don't. And if we look at the output, we can see that the last row with a join key of C doesn't get anything because it doesn't have a matching row in the second table. And hopefully it all makes sense. The important thing to remember that left join always, unless there is a join explosion, the number of rows is exactly the same as in your left table. So we have 3 on the input, and we also have 3 on the output. The right table doesn't matter in this case because it's not in the setting. Now let's go and change it to the right outer join. Now we need to go into this tab where you've got column selection. We've got this default setting here to remove joining columns from the bottom input, because you don't need to have 2 columns that mean exactly the same thing. But for this particular example, let's just keep everything in and run it. So you see, by changing that setting, we will let that second ID column from the right table to be here, because this is right outer join. As you remember, we had 4 rows, A, B, D, and F, with names, and that's effectively the same in this resulting table, which means, yes, it did absolutely correctly. We just got full content of our right table in this case, but also matching rows from the left table. So, as you can see, we get nothing for those 2 rows D and F, because it didn't have anything. It's just written with null, so empty spaces, effectively. Cool. So that's effectively the join, and that's how simple it is to play with it. Now let's have a look at join explosions. In this particular case, what I've got is the table on the left that has 3 duplicates in the join key, and then table on the right, we've got 2 duplicates in the join key of the same value B. So remember, 3 by 2, we expect an explosion to take place. So if we go in here, what we do is we do full outer join, just see what happens overall. Yep, we'll let all columns through. We run it, we'll look at the output, and that's effectively what happens. So as we expected, we got 6 rows resulting from the original explosion of multiplying 3 by 2, because we had 3 of B's here and we've got 2 of B's there. So effectively this is how it explodes. By multiplying 3 by 2, we get 6 rows altogether. Now if we look at the other rows, they just represent what unmatched rows from both sides. This is coming from the left table, and these 3 are coming from the right table. Okay, that makes sense. Now, in terms of checking the how to check for join explosion. So the solution here in KNIME is just to change your join setting to be representation of just one side. In this particular case, if we want to see if the left table explodes, we just change the join to the left outer join setting, run it, and what we get is 7 rows. So now we can actually check that we had 4 on the input, we get 7 on the output. The conclusion is we've got join explosion. That's how we check it. Now and that was from the point of view of left table. If we change it to the right outer join, now we can check if there is an explosion from the point of view of the right table. Because remember, initially we had 5 rows there. Now if we run this join again, we get 9 rows. You see we had the 3 rows that didn't match and the 6 that are created by the explosion, and that's how we check it. So we basically had 5 on the input, 9 on the output. So the conclusion is this table is also exploding. Alright, so hopefully it makes sense to you how we can check for explosions. So the solution is we just change the joiner mode to the left or right, and that's what allows us to compare, like in this case left to left, 4 on the input, 7 on the output. Because 4 doesn't equal 7, the conclusion is there is an explosion. Now let's have a look at another example where we solve the explosion. Remember, the solution to explosions is to make sure that at least in one table the key value is unique, which is what I've done in this case. In the right table there is no more duplication of B. Now if we go into full outer join mode to run it, you can see that for B's that we had 3 on the right hand side, nothing happens, so we still have 3 rows as before, and also all of these rows, they remain in their original state because they don't match to anything, they can't possibly explode. So we had 1 extra row from the left table, sorry, and the 3 rows from the right table. Okay. Now, what if we change it to the right, to confirm the explosion as we discussed just before? Change it to the left mode first. We've got 4 on the input, 4 on the output, so there is no explosion of that table. But let's see what happens if we change it to the right outer join mode. So effectively, after we run it, we had 4 rows on the input. Remember, those 4 rows are B, C, D, and E. So where B, it's only there once. But on the output, how many rows do we have now? We get 6. So we used to have 4, but now we get 6. And why? Because remember, that row, single row with a B value will match to all 3 rows of the left table. So another lesson here, it depends, explosion also depends on from which perspective you look at it. If from the point of view of the left table there is no explosion because there were already duplicates there, but from the point of view of the right table, absolutely there is an explosion because there used to be 4 rows and now there is 6. To prevent explosion altogether depends on your particular context. We'll see later in real examples how we use this, but effectively the simple solution is to make sure at least in one table your join key is unique. But if you have to absolutely eliminate any chance for explosion, sometimes you need to make unique join key in both tables. In that case, everything is 1-to-1, so there is no explosion. Hopefully it makes sense. Okay, and before we finish, I just wanted, for those people who use Excel quite often, I'm pretty sure that some of you, or a lot of you, have tried using VLOOKUP, because VLOOKUP in Excel is a function that does a join. So let's say in this particular case I've got a very similar structure. I've got a couple of repeated rows here, like the value B is repeated 3 times again on the left, and in the right table I've got B repeated here twice, and then a couple of other values. Now the important thing that I wanted to show you, that I wanted to bring this column across to the left table, and I wanted to have a separate label, separate column for first and second instance of the B. And let's just see what happens with VLOOKUP. As usual, VLOOKUP is effectively a formula. You just need to type in what you're looking for, which is that cell there, where you look it in, where you look in, excuse me, in there, in that table. Now I need to press cancel, and then that's effectively the formula for your VLOOKUP. And because A doesn't have any match, it's got not available. Now if I carry it across, this is the fundamental difference between a VLOOKUP and a proper join. You can see that VLOOKUP effectively doesn't go through all of these rows. Whenever it finds the first match, it's done, it's satisfied. So whenever it found the first B, it just grabs that column there and it brings it across. For the second and third instance of B, it does exactly the same. It doesn't bother going and looking through the rest of the table and see if there are other tables or other rows with that value. It's just done. Okay, and that's what I wanted to show you as a key difference with Excel. A proper join will go through all combinations of keys in your tables, whereas Excel VLOOKUP is only gonna pick the first one that it comes across. All right, and hopefully it helps people who work with Excel on a daily basis to understand the difference. And effectively it means that non-Excel versions of joins are a lot more powerful because they don't ignore some of the rows that you've got in your data, which is important. Okay, let's recap. It has been a long video, my apologies, but join is one of the most fundamental tools. It's the main one that allows you to deal with two tables and effectively combine values from both tables into one. Now, in terms of mechanics of a join, you just need to remember that, it's just going through every single row on the left table, then each one of them will be compared against every single row in the right table. And then whenever there is a join key that matches, that will actually create this match, and additional columns from the second table could be brought across into your resulting table. Now, remember that all combinations are considered, and that's the advantage of a proper join like in SQL or KNIME, comparing to, for example, Excel VLOOKUP. VLOOKUP sometimes ignores additional rows, which is not good. Now, join modes, you could see in KNIME, there are four. There is inner join, there is a left join, there is right join, and there is a full outer join. Obviously, inner join only gives you matching rows. Left join gives you all records from the left table. Right join correspondingly gives you all records from the right table. And then full outer join gives you all records from both tables. So that's the mode joins. Next thing, join explosions. Hopefully it makes sense to you. They are caused by duplicates in your join keys, and the true explosion where there are duplicates on both sides. Sometimes it's okay to keep duplicates on one, but definitely not in most cases. And the way to get rid of them is to make at least in one table the join keys unique. Now, it's actually a good segue for our next session that will be about aggregations or summarization, and that's how you make things unique as an example. I'm looking forward to it too. Thank you for your time. See you next time. Bye.